Thank you so much. I'm really excited to be here today. We have three really great expert leaders in the geoengineering space with us to learn from. Just going to give you some brief introductions. David Keith is a professor in the Department of Geophysical Sciences at the University of Chicago and the founder of Carbon Engineering, which was acquired by Occidental Petroleum for $1.1 billion in 2023. Janos Pasztor is the former United Nations Assistant Secretary General for Climate Change and the former Executive Director to the now former Carnegie Climate Governance Initiative, which was an organization that advocated for the importance of establishing governance frameworks for sunlight radiation modification technology. Ryan Orbuch is a partner at the climate venture capital firm Lowercarbon Capital, where he leads the Carbon Removal Fund. There's a lot of confusion in this field because there's some lack of consistency in terms that are used. And so just before we get into the meat of the conversation, I'm going to do a super fast lightning round of terminology definitions, just so that we all know we're all talking about the same thing in this conversation. First off, geoengineering more broadly is the intentional, large-scale manipulation of the Earth systems of this planet in an effort to reduce the impact of global warming. It's worth noting, David is on our panel. He was probably the first to articulate this definition in a paper he published in 2000. All right, so now geoengineering more broadly is divided into two categories. You have carbon dioxide removal and what's often called solar geoengineering. Carbon removal includes technologies that remove carbon emissions from the atmosphere and includes things like direct air capture and ocean fertilization. The term for the second branch of that category, solar geoengineering, that the IPCC uses is solar radiation modification. That means changing the albedo, reflectivity, or sunlight reflection of the Earth. This category includes stratospheric aerosol injection, marine cloud brightening, and even things like using space mirrors. The conversation today is going to focus on stratospheric aerosol injection, or SAI, which involves spraying aerosols into the stratosphere to reflect sunlight away from the Earth and to cool it. Most often, the aerosol that is discussed to be used in SAI is sulfur. Now, lightning round, where I'm going to ask my panelists to step in here to do a little bit more table setting. David, what is our technical capacity to execute SAI today? Is it being used anywhere? Has it been used anywhere? And what research and innovation is needed now so that we can actually deploy?
It's not being used anywhere. It has not been used anywhere. And no research and innovation is necessary to deploy it in the sense that the technological capacity to do it exists today. Let me say a little more about what I mean about that, because I think it's quite important. The physical infrastructure doesn't exist today. So we don't have the exact right aircraft and the ways to load the right sulfur compounds on them. But all of that stuff, the technological ability exists in the sense that some entity, let's say a major country, doesn't have to be the biggest country in the world, could go and procure that from, through a request for proposal process, and would get multiple credible bids in the sense that there's sort of commercial off-the-shelf technologies for developing the supply chain for the sulfur compounds and for the aircraft. You would probably initially start with modifications of existing aircraft and then later build aircraft that can go to higher altitudes. Optimal altitudes are around 20 kilometers, twice as high as a conventional transport aircraft flies. But those aircraft can be built with existing design codes and existing construction methods and even existing engines. So there's no research challenge here. This is a development challenge if that's what we want to do. I believe there's a really pressing need to do research, but that's not the question you asked.
Great. That is all really helpful information to get the conversation, the table set for this conversation. Janos, how is SAI being regulated at a national and international level? And what needs to happen for a productive regulatory framework for SAI to be developed and agreed to?
Well, thank you for this. The simple answer is that there is no regulation either at national or international levels. But let's just remember that we're not just talking about regulation, but the broader governance which includes regulation by governments and, of course, actions by lots of different actors in society. And in that context, some governance is actually emerging, also at the national level and at the international level. We had, for example, the reaction to the Make Sunsets Initiative. Mexico drafted a legislation to ban it. In the US, I understand right now that there is some developments in NOAA to have different reporting requirements for solar radiation modification related activities. And at the international level, we've had for many years now the Convention on Biological Diversity, of which the US is not a party, but many other countries are, that provides non-legally binding guidance to countries on what kind of activities they can undertake. We have a group of scientists who are trying to stop the use of solar radiation modification and the related research. We have attempts at the UN Environment Assembly to introduce decisions to undertake activities which hasn't succeeded, but I think it will come back again. And even the UN General Assembly has some legal framework for governance of the atmosphere, and within that there is some relevant decision. Now, very briefly, in terms of what is needed, I think it's increased societal conversation is absolutely key about the risks, benefits, and governance challenges and opportunities of using or not using this technology, and involving all stakeholders at national, regional, and global levels.
Thank you. That is really great summary. Really appreciate that. And Ryan, going to turn to you. Where is venture capital being invested in SAI right now? And is Lowercarbon invested in any SAI companies currently? Are there any plans to do so that you would want us to talk about publicly?
By and large, there's essentially no venture being invested in SAI at this point. We have not yet made investments in the space. I think the way we see it is we invest across three main areas: emissions reduction, carbon removal, and then sort of a historically smaller category that we've referred to as sort of buying more time, or more broadly, climate adaptation. So far, companies in that area are providing new forms of fire or flood insurance, or helping emergency management associations respond to weather and natural disasters and those sorts of technologies. We don't see sunlight reflection as necessarily categorically different than some of those other buying more time tools. But I think the way in which it's structurally different is that, to David's point, I think the only practical customer in a scaled way to do sunlight reflection that would matter for the climate is a government or coalition of governments. And so far, no governments raised their hand and offered to purchase this, right? I think, to David's point, like, the way you'd see this play out is very plausibly some notion of a government contractor, government procurement relationship, but that would bridge potentially startups, heavy industry, existing aircraft manufacturers, existing chemical manufacturers, and like actually doing this in practice looks like running a small, diplomatically sensitive airline. So we have yet to make sort of specific investments in this space, but we think that as the damages of climate change continue to mount, the idea that this deserves serious consideration and could be done in the coming decades, I think we'll take quite seriously.
Should for-profit startups be investing in SAI? And if so, how can they do so responsibly?
Okay, happy to react. And should they or should they not? It's a challenging question, and especially if we look at the atmosphere, the one global atmosphere that we have, which is considered as a common global good of humankind. And in a perfect world, one would imagine that governments, like Ryan, you just mentioned, that governments would decide to do or not to do. And if they decide to do stratospheric aerosol injection, then they would decide how to delegate parts or all of those activities to the private sector, right? As they often do for different areas. But unfortunately, we live in a very imperfect world, and it's getting, in fact, even more imperfect by the day. And the reality is that we have actors, some for-profit and some for not-profit startups that are actually engaged in doing research and development in this area. They exist. And I suspect that others will follow. So, and they're doing this in a context where there is no governance, there is no societal acceptance, or for that matter, rejection of this technology. And governments are not taking their responsibility seriously, in my view, by sort of ignoring what's happening. And So in that context, I could share with you, if it's okay with you, a few points that I learned in my work with this one of these startups, the Stardust company, who asked me as an independent consultant to write a report about governance challenges that arise from their work. And I could share with you 9 points very briefly, and maybe we can discuss them one by one. I think the first point was that I felt that they have to really go out of their way to go beyond the immediate needs of the investors. It's something that can be done, and they need to do that. So it's not just simply about money. The second is that they have to be clear that the actual solution to the climate crisis is emission reductions. And yes, stratospheric aerosol injection can be a supplement, a time-limited supplement to the actual solution to address some of the impacts. And that, I think, would help to reduce the moral hazard argument quite a bit. The third is that, and I think, Ryan, you mentioned that already, that it has to be states, sovereign states, to decide whether or not to deploy, and if yes, how and by whom, and if no, how to deal with the implications. Now, undertaking research and development, I think, is very different than actual deployment. And I think I think we would agree with that. The fourth point is that they can encourage development of governance frameworks. Things are happening, and these companies can also participate in one way or another to help these processes along. The fifth point is that they can encourage a moratorium for deployment until the knowledge, the sign of the risks, the benefits, and the governance challenges raises to a point where one can make evidence-based decisions on whether or not. And that, I think, also helps in the so-called slippery slope argument. The sixth point is that they have to adapt a very high level of transparency, as much as the IP process, the intellectual property process, allows, about what they're doing and what they're planning to do. And in that relation, also undertake active outreach, but in part to ensure that their work is scientifically reviewed, and in part that they engage with some kind of advisory group to get the inputs from different stakeholders. The eighth point was that they can actually develop their own voluntary code of conduct until actual regulation is available. And finally, to explore options for how to deal with the IP. How can one make it freely available to governments, or how can non-profit actors perhaps engage to purchase the full rights? There are different ways of dealing with IP, as we have seen in the past with different technologies. So that's something to explore further.
What is the state of the scientific knowledge about what would happen if we deployed this? And I think that's the most important thing that drives or ought to drive people's decisions about how to regulate, what to do. I think the answer is that if you look at all this climate modeling over now 2 decades and broad climate science, if you're talking about hemispherically balanced and relatively small deployment, the evidence appears very strong that such deployments would reduce most of the major climate hazards almost everywhere. It's really quite kind of stunning. The big question is, can we trust that science? What's the probability that science has missed something? And I think repeating the same climate model experiments won't work so well. What we need is more trusted assessments and a different kind of science that focuses on finding the gotchas, the unknown unknowns, because that's the central question that at least concerns me, and I think ought to concern decision makers. Moving on from that to corporate involvement, my position is that I'm deeply skeptical. I'd say I oppose involvement of for-profit companies in the core SRM technologies. And here's why. I think companies are great, or can be, at innovating to reduce the cost of technologies in the cases where purchasers can pretty easily evaluate for themselves what the technology does. So if you're talking washing machines or wind turbines, with appropriate controls, capitalism can work really well. But for solar geoengineering, as I kind of just said, the challenge really isn't innovation so much. And it's really not, in some sense, a new technology. It's applying a broad piece of science that's been evolving for 100 years. The question is trust in the predictions. And I don't think that public companies or private companies do a good job generating that trust. That's in general not who we turn to for predictions like that. Companies, in fact, I think are singularly bad at that. They are inevitably internal dynamics where they tend to exaggerate how well something works and play down the risks. And so And finally, one other crucial thing I didn't say. You asked me earlier about whether it was deployable, and I said yes. I didn't mention that all that could be done initially for costs that are really quite tiny compared to the cost of other climate actions, costs that without any innovation are at the order of a few $1 billion a year today to kind of get started in a serious way. So cost is, if you like, not a problem that solar geoengineering has. The problem is trust and uncertainty, and those don't seem like things where private innovation is likely to be that useful. To be clear, any action that gets done involves some private suppliers. I mean, there's supply chains to do things. So if there really are aircraft doing things, there will be private supply chains to do them, even if those aircraft, which could or could not be actually owned by governments. So I'm not saying zero private involvement, but to me, the issue is private involvement in the core technologies for actually understanding and monitoring this idea.
I think maybe two things. First off, David, the idea that we should just arbitrarily trust some private company to both like do and then also check the entirety of their work and tell us whether or not it worked. Totally agree with you, right? I think that there will be roles for private industry, both as technology providers and sort of core system suppliers. And I do think there might be more room for innovation than it appears today. But in general, this is sort of why I keep going back to, in practice, this gets done in partnership with state actors, and their procurement processes and their regulatory processes for this must provide a sort of check on anyone's pitch, right? And like the reason I don't have a sort of, like the rogue machine of capitalism will take the world into a deployment that nobody wants is that there's no revenue on the other end of that today, right? Like in practice, like some wealthy person throwing billions of dollars into deployment with no specific state backing and no specific customer on the other end, this is actually more like a philanthropic endeavor than a business, right? And I think like the importance of the technology and innovation work and the importance of, additional research on the climate impacts, additional research on governance and so on, is so that the world's governments can understand that like this actually might be an option on the table.
Totally agreed. So I agree with you about who the actor is, but I think the big question is, if there's some company that has some particular technology, they're going to be trying, because it's in their interest to do it, even if it's also true that they sincerely believe it, to pitch it to governments in a way that shows as well as possible how great it is and downplays the risks. And it seems to be like,
yes, and governments need the capacity to evaluate that.
Correct.
Right.
Yes.
Like I'm totally with you. Right. And I think that there will be both good and bad actors pitching their thing. Right. And I think to believe that this is going to get deployed effectively and safely, a lot of what we need to do is build the capacity for state actors to evaluate the impact of these things, both on their country, on surrounding countries, and on sort of the geopolitical.
Great. But that's fundamentally through the atmospheric and environmental geosciences. And there we have things happening. Actually, one of the international things happening that's quite important that Janos didn't mention is the very acronym-y and boring sounding, the World Climate Research Program, which is one of the oldest and most stable international organizations, period. Has a thing called the World Climate Research Program as part of that. And there's now a lighthouse activity, a formal activity that's international goal-setting, real activity for internationalizing SRM research. That's the kind of thing that I think builds research capacity and trust.
Yeah, no, I totally agree with you there.
Yeah. I'd like to come back to a word that David used quite a lot, trusted. And I think that's really important. And I'd like to compare how that works both in the intergovernmental world and the private sector world. So one of the reasons why when I was working with Stardust, with the company, to work on the transparency and the outreach is precisely that they develop a certain level of trust. Now, whether that will work 100%, we'll have to see. But that's the idea behind that. At the same, if you think back at the intergovernmental level, and we worked on this quite a bit in my previous work, that the lack of trusted information about this issue was very important. So when UNEP finally produced this expert group report, the One Atmosphere, the UN Environment Program, then suddenly there was something on the table that people could trust from different countries, from different parts of the world. Now, that's just the beginning. It's not the end of the story, but it shows that this trusted information is absolutely crucial to get the governance discussions going and then eventually getting concrete governance actions done.
Yeah, agreed. I think one of the things that's important to understand about this, though, that's sometimes missed in some of the more technical discussions is like, it is fundamentally the case that no matter how quick and effective we are at emissions reduction and how quickly we can scale carbon removal, both of which are, consist of the vast majority of our investments, right? Like that's our incentive, is those two things. The sunlight reflection is the only thing that can impact like the specific climate damages that like many people in the world alive today are going to feel, right? And it's the only thing that can work in years, not decades, right? But it's also in many ways like a buying more time and Band-Aid solution, right? It's not a substitute for emissions reduction and carbon removal, but it can mitigate the damages while we scale those things up. And that's both around the world and in the global south. But it's also, my mom lives in North Carolina, right? They had a hurricane there last week. I don't know when this is going to show, where farmers who were out of even federal floodplain requirements can't even like claim flood insurance because they were in that floodplain, got just like totally wiped out last week. And the idea that we can keep telling these people like, no, just reduce emissions harder and you'll be okay. Like that's not a sufficient like way to address the impact of it on people's lives in the next few decades. And like, that's why I think work on this is important and why like governments and other actors need to start taking it a lot more seriously as a nearer term thing to consider.
Well, I just want to ask one question so while there's some just discussion about whether or not and how private investment in this topic can and should happen, what do you guys think? Are there other aspects, other ways that funding should be going towards this space?
Well, government funding be crucial, the public funding for further research, and very interesting new development in the UK, the ARIA process, where suddenly there is, $75 million worth of money, public money available for research. Very interesting development, and that is a lot more of that kind of support is needed, I think.
Strongly agree. And I think it is worth thinking about the comparison between this and carbon removal. So they're both different from emissions cuts. Emissions cuts reduces the amount of atmosphere we will put in the atmosphere in the future, the amount we do make the problem worse. But emissions cutting does nothing to deal with a problem we already have. We could cut emissions to zero tomorrow and we'd still have the warming we have. The only way to deal at any given time with the warming we have is either carbon removal or solar geoengineering or some combination. That's the only way to deal with it globally. There's local adaptation. And I think there's really interesting ways to think about the risks between them. I worked for now 30 years and done lots on both carbon removal and solar geo, and it's normal for people to say that the issue is just the carbon removal is very expensive, but it's inherently a lower risk thing. I actually don't buy that. I think if you look quantitatively at comparisons of carbon removal and solar geo used to achieve the same end, a small reduction in temperature, say mid-century, the way at least I do the math, carbon removal typically looks more risky in terms of actual impacts on the ground.
But at the end, we probably need both, right?
You need to have the capacity.
There is already too much carbon in the atmosphere, so at some point you'll have to remove some, whether it's a few gigatons or many gigatons, that's a question.
For sure. I think of carbon removal as something that is vital if we want to restore the environment we had mostly after emissions are mostly down, then carbon removal is the only way to reduce the long-run risk. Whereas I think of solar geoengineering as a way to reduce risk during the time that CO2 emissions and CO2 concentrations are at their peak.
Yeah, I agree with you that the sunlight reflection reduces risk while concentrations are at their peak. I think the relationship between that and carbon removal is that, apart from the vast sort of like technical and engineering differences in the two, right? Like just to set the stage for this for a second, like when we think about carbon removal, we think a lot about mass transfer, right? Like how much material do you need to move to take that amount of carbon out of the cycle? And that can be moving air in a direct air capture machine. That can be moving rocks in an enhanced weathering or ocean alkalinization context and so on. And generally you've got to move like a ton of carbon to get a ton of carbon out of the air, right? And to move, 10 to 20 gigatons of carbon out of the air, like we hope to do as carbon removal scales over this century, you're talking about moving on the order of the mass that a number of heavy industries move today, right? Coal production is about 8 to 10 gigatons a year, just for like physical context. With sunlight reflection, we're talking about a few megatons of material placed very specifically to be able to have the impact of, essentially 1,000 gigatons of carbon.
It's a million to one ratio.
Exactly. Yeah. And that's really significant, right? And it is like so significant that it certainly isn't a substitute. I think that carbon removal plays an even more critical role in the world where sunlight reflection happens, because it enables us to taper down safely. But in practice, like, the speed and scale that it can be deployed is unprecedented in sort of climate intervention broadly, right? Like, there's no way we can change the grid this quickly. There's no way we can change the power system this quickly. Like, it's really structurally different in that way. And I think that, that's one of the reasons that more attention on this issue is going to be inevitable. And it's really important that the research is done by thoughtful actors, and that the engineering and technology systems are actually built so that if the world wants to do it, it's actually there to use and not like scrambled haphazardly.
Strongly agree. Just to put one numerical context. So, because it's easy to think of putting sulfuric acid in the stratosphere seems so dangerous. But for context, humans put over 100 million tons a year of sulfur pollution in the atmosphere at the peak of pollution in the mid-70s. And a big volcano like Pinatubo put 8 million tons in the stratosphere. If you wanted to cool the world 0.5 degree centigrade late century, which would be a gigantic human benefit, saving hundreds of thousands of lives a year, I did not make that up, you need to put in 1 or 2 million tons of sulfur a year. And that is a really tiny number compared to those 100 or 8. And that tells you that we know a lot about what those consequences are.
We're already getting towards the end of this session, which is mind-boggling because I feel like this conversation is just getting started. But last question to all of you guys, sort of in the final words. If we're going to talk about government funding, that's one thing that I think you guys have all said, is that we need more funding for research. Government would be a great place for this to come from. That definitely also comes back to this trust issue, right? If we're going to ask government to fund an idea that they don't understand or trust yet, how can we increase the trust? How can we communicate better? How can we initiate and build some of that trust?
I would start with the fact that until we're able to engage fully different parts of society in a conversation about what this is all about, the kinds of issues we were talking about now in this debate here, it will be very difficult for governments to do something, because governments will do something where they either have a strong political pressure or they really feel that something has to be done. And at the moment, neither is there. So that won't solve all the problems, but I strongly believe that serious societal conversations about this range of issues by different actors will help to eventually create the conditions where governments will just have to figure out whether or not to make use of this technology.
I think the best preconditions for trust are that research be as global as possible, but be researchers really distributed all around the world because people trust people they know more, and that research be open, completely open access and transparent. And then finally, I think that there not be excessive or really maybe any significant action by for-profits. I think that reduced trust in this area.
I think that totally with you on sort of the research transparency broadly. I think that maybe the one piece that hasn't already been mentioned by the folks who are more expert at it is just that this isn't even a thing that most governments are aware of, right? And like, it's hard to even talk about trust when they just like haven't heard of the thing and it has radiation in the name and it sounds scary, right? And I think that, there was some UN resolution in the environment program around additional research on this area, which was sort of notably in the press, rejected by a handful of countries in the global South. And, I spoke with a friend who was involved in the resolution, and he spoke with the delegate from one of these countries shortly after they sort of expressed their displeasure with the resolution. And it was mostly in the context of, well, we don't know what that is. Right. And I think like that is a level of like, that is both the sort of NGO and scientific community not necessarily stepping into their role as sort of just explainers of the fundamental science on this, regardless of any specific view on whether or not it should be done. Right. And like, this deserves a conversation with government leaders that have the basic facts of what's on the table. Right. That this has benefits, has trade-offs, could be deployed very quickly, could be very inexpensive. It is the only thing that could affect your constituents' lives with their respective climate damages during the time you're in office, right? That may mean we want it, that may mean we don't, but like some of those basic table stakes have to be part of the conversation to really understand public trust and public response.
Just very quickly, I think governments, most of the time, they are now aware of this issue. They don't want to deal with it. That's a different problem.
I know this whole conversation is just getting started. It went by in a blink of an eye, but I just want to say thank you to all of you. I really appreciate having this conversation and appreciate all of your expert opinions.
Thank you.
Thank you.
Thank you.